Okay, folks. So on the example here, we're looking at the same data from yesterday, data which describe a ball being thrown up in the air and then falling down to the ground. Yesterday, we determined an equation for those data, and we're going to put that equation into Wolfram Alpha now. We're going to put in y equals negative 4.9x squared plus 10x plus 2. And notice I used the caret symbol, the little up arrow, to show x to the power of 2. I got that by holding shift and typing in the 6. So if we just hit enter now without doing anything else, we will see that Wolfram graphs our parabola for us. And it's similar to what we had yesterday, especially if we ignore everything with negative time or negative height. Those don't make sense. If you really want to visualize that with Wolfram, you can. You can tell it, I want x to be positive numbers only. I want y to be positive numbers only. And it will show you the graph exactly as we saw it yesterday, with the ball going up and coming down. But generally speaking, we're going to leave those things out because we don't want to confuse Wolfram too much. What the question is asking us to find is the highest point on the graph. Where does my ball reach its highest point, and when does my ball reach its highest point? So I'm going to ask Wolfram to maximize this equation. And it does that, and it finds a maximum, and you can see it even redrew the graph for me and showed me the highest point. Now, my maximum height is this weird fraction, and it happens at this weird time. I don't really want to deal with those, so I'm going to come up to where it says approximate form and hit that. And now I see that my maximum height is 7.1020 meters, and it achieves that maximum height at 1.0204 seconds. So these numbers are my answers. This is the maximum height, and this is when we get there. If you have your legend telling you that x is time, then you're pretty good to go here. So this is one of the things that I can do with the equations that I'm getting out of Excel. I can find out important pieces of information like the highest point that that ball reaches. Okay, so there's a second part of what we're being asked to do here, and that's to use Excel to kind of implement our equation and to figure a few things out. So if I start a new Excel book, what I can do is I can set up my time gone by and my height. And I can start with a time of 0 seconds. Why not? Oops, I have dollars here. Let me turn this all back into not dollars. Shoot, sorry. Okay, so I'm going to need to use my formula in this box here. Now I know my formula is that my height, y, is equal to negative 4.9 times x squared plus 10x plus 2. So I'm just going to keep that there for me to look at, and then I'm going to implement it in this box here. I'm going to zoom in a little bit to help us see what's going on here. Okay, so to implement a formula in Excel, you might remember from a few years ago, we're going to start with the equal sign. And then we're going to write exactly what we have here, only we're going to make it clear to Excel that when I have an x, what I mean is the value in the box next to it, the value in the cell A2 here. So I'm going to type negative 4.9 times A2 squared, right, plus 10 times A2 plus 2. So you can see my overall formula here up in the formula bar, negative 4.9 times A2 squared plus 10 times A2 plus 2. And it works out to 2, which is good because if I check back on my data, the height after 0 seconds is 2. Let's try some other things. Let's try the height after 1 second. 7.1. That matches my data. Let's try the height after 1.5 seconds. 5.975. That matches my data. Let's try the height after, I don't know, 0.75 seconds. Whatever I pick, I can find the height at exactly that moment. So for the question that we are dealing with here, where it asks us what is the height of the ball after 0.05 seconds, or 0.15 seconds, or 0.25 seconds, we can do that. We can put 0.05 in here, and we can find the height. And if we wanted to do it for 0.15, and 0.25, and 0.35, and 0.45, and whatever, we would just have to use this same formula over and over and over again. And the nice thing is, by clicking on this black box here and dragging down, I can get all of those numbers. So there we go. We have successfully used Excel to implement our formula. And now we can calculate the height of the ball at any time we so desire. And using Excel and Wolfram as a tool, we can now make use of all those equations you generated yesterday, which is the goal for the rest of the class, or at least the first half an hour or so of the class today. So give that a shot.